Today we're talking about mineral identification. In particular, we're going to be using Chapter 1 from Ocean's book, Insights, a Laboratory Manual for Physical and Historical Geology. The picture you see right here, and you see a person standing here for scale, was in a silver and lead mine down in Mexico. This was taken in April of 2000. National Geographic did a very nice bit about this if you want to go dig it out. We won't be dealing with anything quite that big in class today. Minerals and mineral identification creates a lot of concern among students. It can be one of the more difficult areas for students. I'm trying to demystify some of it today. It's really not so bad. Most of our minerals, though not all, we find in the crust are what we call silicates, a mixture of silicon and oxygen. As you can see, most of your rocks are made of silicon and oxygen, with some aluminum, iron, calcium, sodium, potassium, magnesium, and a little bit of a few other things thrown in. There's only between 20 and 30 minerals that are common to worry about. We've actually got some variations here. We have 32 that we're going to worry about in lab. All right, you'll be given this mineral sheet here to work with in lab when we get to that. We could break minerals into two main groups. One are rock-forming minerals and everything else. And this, if we have a magma chamber starting to cool down, we'll start to get some minerals that will solidify and fall out. We have two groups, a discontinuous branch where we get one mineral, then another, and our continuous branch where we start with our calcium-rich Plagioclase Feldspar, and it winds up a sodium-rich Plagioclase Feldspar. As the magma chamber cools, different forms of this will fall out, depriving the magma chamber of the calcium and thereby becoming enriched in sodium. The first one here on this branch is olivine. For our purposes, it's real easy to identify olivine in class and in lab. If it's olive green, it's olivine. Real straightforward. Then we will start to get our pyroxene. It is black with some green mixed in it sometimes. You see this shine here and here. We'll talk about how to identify this in a minute. And the next one we get is amphibole, the amphibole group, primarily hornblende. And here's a specimen here. We'll talk about that more in a moment. And then you'll get your biotites, and as this is has a what we call a vitreous luster, and you can peel it apart in flat sheets. On this side, we start off with our calcium-rich Plagioclase Feldspar, which is very dark. And you see these little lines here, these little striations? That is a dead giveaway for Plagioclase Feldspar. This is dark, it's rich in calcium. This one is rich in sodium. It's light in color. Okay, it's called albite. The other one's called labradorite. And if we get it just right, you should be able to see the little striations in it. But I have to get the light just right. Okay, and whenever you can, when you find it, that is absolutely diagnostic. Okay, now these are rock-forming minerals. We also have a whole group of minerals that are not part of that. Some of them are straight-up native elements, gold being one of them. Okay, sulfur over here being another. Here it's pale yellow color. and a real bad smell, like if you strike a match and then you blow it out, that unfortunate smell, that's what we're getting, okay? So those are our native elements. Several things can be useful to us. Crystal shape. This is a cube. Several minerals. You can get pyrite in this shape, very rare. Galena, halite is shaped like this. These, it looks like two pyramids, bottom to bottom. That's going to be fluorite. Diamonds are like that as well. This one here looks like a cube that someone knocked it off of 90 degrees, called a rhombohedron. This is how we'll find calcite, all right? Another thing is fracture and cleavage. Fracture is just simply a break. Cleavage seems to give students a lot of hassle. I'm going to try to make that easy. Here is a cleavage plane, okay? It's nice, smooth, even cleavage plane. Here, in this cartoonogram, a smooth cleavage plane like this, it breaks along a plane of weakness. You see the light going off in the same direction. Even if it's not as pretty as this one, the light, they're all parallel. The light is still bounced away in the same direction. Here, for a fracture, it's just kind of, the light will be bounced in all sorts of directions. So when we look at this, if I hold it just right, you should be able to see inside of it. Can you see right here? That's where it's looking to break already. All right? You see how this has got, these two are parallel. That's one cleavage plane. This side and this side are parallel. That's another one. So here we have three cleavage planes, all at 90 degrees. And here, you can see where it wants to break right here. Let's try it from this side. Can you see that? Right through it. Right through it. It wants to break right there. All right? This has cleavage. It would break into smaller and smaller cubes. This particular one is called halite. It's basically table salt. All right? So that's cleavage. We can see cleavage as well in this calcite specimen. You see right here where it wants to break along a plane of weakness. All right, and would break into smaller pieces that have this same shape. Notice that there's not a 90-degree angle on this thing anywhere, no matter how we turn it. All right, that's calcite. This, of course, is a quartz crystal. You recognize that. Most everyone does. This does not have cleavage. If you break it, you will not get little pieces shaped like this. All right, cleavage breaks along planes of weakness. Another thing we'll talk about is hardness. You can scratch it with a fingernail. It's gypsum or talc. Talc has a greasy feel or soapy feel to it. Gypsum, usually you can see through it. It's in the same group as the calcite, but it comes in little flat wafers. So you can only really see one side well, but you can scratch it with the fingernail. I think you can see the scratch there. All right. I've already scratched it a couple of times today. All right, there you go. Okay. So if it's softer than my fingernail, it's going to be gypsum, unless it has this feel of talc. We don't have any copper pennies. They're hard to come by. They're not made of copper anymore. Nail. You'll have a nail in your kit and a piece of glass that you can use to see if you can scratch something. If it scratches glass, it's going to have to be up in here, one of these. Probably not a diamond. Trust me on that one. Here's what I tried to show, a picture of what I tried to show you a while ago. These, it grows this way. These little, they look like parallel scratches, but that's how the Plagioclase Feldspar will grow. This dark one is calcium-rich labradorite. Calcite has another interesting quality. It will fizz in hydrochloric acid. Now be very careful with this. I had a young man get into this in the field and put it in his eye. So don't get careless in mineralogy lab, okay? And you can see that effervescing. Make sure you wipe it down real well and wash your hands. Don't put your fingers in your eyes. All right. Here we see color is useless in calcite. Here is 3 specimens. None of them are the same color. Okay? They all have the same rhombohedral shape, and they would all fizz in acid. So will limestone and marble. Color is good for some things. This is limonite. It's kind of an orange color. Some of them are a little darker color. Shape is no good. Crystal shape is no good. Cleavage is no good. But the color pretty well as it gives it away. Pyrite has a metallic luster. This piece here is very rare to get it in a big cube like this. Usually you're going to find something like this. You can use your hand lens to blow this up, get a little bit better look at it. Okay, you should have one of those in your kits, or they'll be available to you as well. Alrighty. What we're doing now is just walking through the pages of the lab book, so you come a little better prepared. These are different color varieties of fluorite, but as you can see, the shape, like 2 pyramids, bottom to bottom, is a dead giveaway here. Another thing is called streak. You will have a streak plate. You have 2 of them, a black one and a white one. This black streak here is from magnetite. This is from hematite. Magnetite has another lovely quality. Magnet will stick to it. Have one of those in your kit. Hematite can be this almost black reddish color to something a little bit more brighter. Gives you this nice reddish brown streak. Be careful though with the hematite, because some of it, like this particular specimen, has some magnetite mixed in with it. Okay, remember these things come out of nature, not off an assembly line. Okay, so if it's a white or colorless streak, we'd use the black streak plate. All right, so streak is one of the giveaways for what we're trying to accomplish here. I've already mentioned magnetite has a magnetic, a magnet will stick to it. And then I want to go through through the book itself. You have these steps and the methods you can follow. You get over here to your charts. First you decide, do you think that your specimen has cleavage or not? You say we think it does. Then we use the streak plates. If we get a colored streak, let's go up here. If we get a white to clear streak, we go down here. Then we get to worry about the cleavage planes. You have the one plane, the basal cleavage. If it's clear to white, it's muscovite. That black, shiny, vitreous one is biotite. If it feels, you can call it soapy. To me, it's greasy. It's going to be talc. Don't worry about these others. You're going to only have the ones that are on the list I give you. Here, if it's amphibole, this is going to be dark in color. But you get a cleavage plane here. See where the light glistens off of that? That's one cleavage plane. And here is another. If I get the light just right. And you see that's not 90 degrees, okay? So that's part of the amphibole group. If they are at about 90 degrees, that, like we see here, so your one cleavage plane here and one here, and that's 90 degrees. It's a small specimen. It's kind of hard to see, but that's 90 degrees. Here's the ones with 3 cleavage planes that we've already talked about. The halite, table salt, it's clear. You can see through it. All right. By the way, it has a salty taste, but don't try that. Some minerals apparently are toxic, and generations of students who weren't paying attention have dropped acid on it. Then we get into the calcite, that rhombic shape I discussed with you, and then the gypsum. It will not fizz, and it comes in like thin sheets, but more like little wafers. And then the fluorite with the 2 pyramid shapes back to back. If we get into the feldspars, brings us down to here. Here's the pink one. Okay. Pink potassium feldspar, okay? And you see there's going to be some variation here. No 2 of your kits are going to look exactly the same. This did not come off an assembly line. It comes out of nature, so there's going to be considerable difference. The striations I told you about, the light colored one is albite, the dark colored one is your calcium-rich labradorite. Now let's say you've gone through this, but you can't find what the mineral is. Well, maybe you were wrong about the cleavage. Let's go look at the ones with no cleavage. Okay, maybe it's one of these. Well, is the streak got a color to it? If so, what is the color? Is the streak clear or white? Then let's look at the hardness. All right? And just go through this. This should get you through it. Howsoever, on occasion, you might still have trouble with this. Then you have this table to go to. Is it metallic mineral? This is galena. It's very heavy. It's also shiny. It looks like jewelry. This is a lead mineral. Notice it is a cube. 90 degrees, cleavage in 3 directions. All right? Very heavy. Once you get used to this, you won't confuse it with anything else. All right? Pyrite also has a metallic luster, but it has got it's a brassy color. Chalcopyrite will have a little bit more orange to it. And here's your hardness. You can check the hardness, your streak, and then some properties that are going to be asked for on the worksheets. You can take those. Once you've identified something, even if you use the other sheets, you come over here and get the rest of the data. All right? And if it's non-metallic, then you have several sheets of this. All right? So, a couple of things. I think I have been over just about everything, except I want to talk about the quartz. Quartz comes in quite a wide variety. I have a couple of crystals here. This is a little pink to it. It's rose quartz. You'll have a white, cloudy one called milky quartz. You'll have a dark gray one called smoky quartz. And this is one of my favorites. This is amethyst. It's purple quartz. All right? And these are your rock-forming minerals, your quartz, your feldspars, olivine, this sort of thing, biotite. All right, these are our primary rock-forming minerals. The others that we'll talk about, graphite, soft, and gives you it looks like pencil lead because it's pretty much what it is. That will be harder to identify unless you've looked at this, but it's that streak that'll be the giveaway and the softness for that one. I think that about covers it. Look over this again if you need to. Make sure you have looked at your lab book before coming to class, and that you are prepared for the lab. Always come prepared. Look through the material before you get to class and before you get to lab. Make life go a lot easier. We'll talk to you in a later video.